Team Bill 9 presents the Bubble Blower TM, featuring...
Hello, my name is Nathan Comer, and I want to be a mechanical engineer.
Hello, my name is Ryan McDonald, and I want to be a computer engineer.
Hello, my name is Jonathan Wendrock, and I want to be a biomedical engineer.
Hello, my name is Yue Zhang, and I want to be a materials science engineer.
For Milestone 1, we had to ask ourselves, how do we create a bubble-blowing machine that produces a high volume of bubbles, alternates bubble frequency and size, and keep the design within the $40 budget? For Milestone 1, we also had to consider what our bubble blower would be judged on, which are the following criteria: having no commercial bubble-blowing parts, an original bubble solution, being automatically powered by one power source, the ability to operate for 1 continuous minute, and the ability to make bubbles. In addition, points will also be awarded to designs that allow for a change in bubble size, allow for a change in bubble frequency, create a high volume of bubbles within the minute, show creativity, uses a non-electrochemical battery-powered source, and shows high-quality craftsmanship.
So we did lots of research.
To figure out what we were going to do, we did research on bubble blowers, bubble wands, and bubble solution, and began to formulate designs that we could create and win FEDD with. To sum it up, Milestone 1 really got us on track.
Design 1. Double discs.
In this design, there will be 2 oppositely facing Ferris wheels spun by a small but high torque servo motor that can be powered by a 9-volt DC power supply. We will also obtain 2 small computer fans to blow constantly toward each Ferris wheel to blow the bubbles. There will be a basin of solution under each Ferris wheel that the wheels will dip into, replenishing the solution in the bubble wand circles. In our analysis, we accepted this as a possible idea because the design is feasible, can be easily built, and we could 3D print the Ferris wheels. The total cost would be manageable as the fans and motors are in our price range.
Design 2. The waterfall.
In this design, there will be a tank of bubble solution with the pump pushing the solution over an edge and onto mesh to create a waterfall of bubble solution. A fan will then be placed behind the waterfall, blowing the solution through the mesh to create bubbles of varying sizes. In our analysis, we accepted this idea because it needs further testing, but is possible. It would be difficult to construct, however, the bubble output could potentially be very high.
Design 3. The wind turbine.
This design would include a Ferris wheel as mentioned in the previous design, however, fan blades would be attached to the outer edge of the wheel to allow it to be wind powered. The wheel will have a basin of solution below it that it spins through to replenish the solution in the wand circles. Then a fan will blow on the wheel and through the wand circles, both rotating the wheel and blowing the bubbles, so that only one part requiring electricity will be used. In our analysis, this idea was rejected because the fan needed would be too large and the overall design would be impractical. Additionally, the only reason this design came to be was due to a typo in the initial design constraints, stating we were only allowed 6 microwatts of power.
Design 4. Taste the rainbow.
In this possible addition to the other designs, different bottles of bubble solution will be interchangeable in the basin, providing either different colors or flavors. The bubbles will be colored by using food dye mixed with the normal bubble solution, and flavoring would be achieved through having a standard recipe for the bubble solution, with the additional step allowing for the addition of flavoring. In our initial analysis, this idea was accepted, however only as a secondary objective if all other objectives were completed early. Upon further analysis and help from our FEDD instructor, it was realized that flavored bubble solution is too dangerous and should not be used.
Design 5. Too complicated.
This design would be constructed using a motor, bubble wand, and an Arduino. The wand will spin in a circle via the small motor, and under the wand there will be a reservoir of bubble solution. The motor will be connected to the Arduino and coded to spin slowly when going through the reservoir and accelerate for the rest of the revolution until it meets the reservoir again. By doing this, the acceleration will create bubbles and the wand can recharge in the reservoir. In our analysis, we rejected this idea because the Arduino is too expensive, no one in our group has relevant coding experience, and it has an extremely low bubble output.
For Milestone 4, our main goal was to conduct model development and testing. To accomplish this, we use SolidWorks to CAD out our entire design and get all the dimensions we need for the final construction. Also, we 3D printed our discs out and tested them to see if they could produce bubbles, which, if blown by a human individual, they could. Finally, we evaluated the model with the respect of what we would be judged on, and we found that we were in the clear. We had double discs for maximum bubble output, solar chargers so we could receive the points for not using electrochemical batteries, and we had creativity and craftsmanship down pat.
To complete Milestone 5, we had to complete at least 75% of the bubble blower 1 week before FED. We also had to say how similar it was to Milestone 4 and why things changed, if any. Overall, we did meet our goal of 75% completion, and our final product was about 85% similar to Milestone 4. The reason we say 85% is because we had to completely redesign the discs that blew the bubbles, due to the fact that the original design had the holes too close, as well as the bubbles were not being detached from the disc as we had hoped. So, we had to go through a couple of new designs to reduce the morphing of the bubbles and to allow the bubbles an easier time of detaching from the disc. In the end, we accomplished this with our newest design, the Ferris Wheel Mark IV, which was debuted at FED Day. Final design is symmetrical. On each side is a basin with a ramp. The ramp will force a large majority of the bubble solution that is used by the Ferris wheel to not go to waste. There will be a PVC pipe that goes through the center. This pipe serves two purposes. One, to ensure that the amount of bubble solution in each basin is at an equal level, and two, to make it possible to only have to fill the machine from one side, which increases usability. Offset from either side of the center will be two upright pieces of acrylic. Here, we have attached the fans that blow the bubbles. In the empty space, in the center of the machine, is where the solar power source, motor, and other electronics are held. This section will be sealed to make sure that none of the solution is able to make its way in and cause an electrical hazard. There is a plate of acrylic that slides out to ensure easy access to these electrical pieces. There are two slide locks on the outside to keep the electronics in place during use. The axle of the motor drives a pair of gears with a reduction of 4.5. This is so that the 30 RPM motor can drive the axle at 135 RPM. There will also be a potentiometer on the wall of the slide-out plate, which will work as a power meter. Based upon the direction it is rotated, it will either increase or decrease the speed of the motor, thereby changing the output speed of the axle and the Ferris wheel, which, in turn, increases or decreases the frequency of the bubble output, respectively. There is also a top made out of acrylic, along with some mesh sides, that will prevent anyone from sticking their hands into the center section, which could be a safety hazard.
Confetti, it's a parade!
So when we first got to FED, we weren't entirely sure that our design would succeed.
The night and the morning before FED went terribly wrong, as everything that could have broke did in some way.
Because of this, we weren't sure of whether our bubble blower would fully seal, which if it didn't, we wouldn't be able to compete as it would be an electrical hazard.
However, we are glad to announce that everything worked when it needed to, and we brought back the first place victory at the 17th annual FED competition morning session.
Though our design didn't end up creating the most bubbles, it did thoroughly impress the judges as it was well crafted, had a very unique design with its clear construction and double wheels.
Overall, FED has taught us many things, and we are proud to be engineers.